Welcome to this video on interval estimation of the population mean. First of all, the lesson goals are to construct a confidence interval known as CI for a population mean when sigma is known, sigma being the population standard deviation. Secondly, construct a confidence interval for a population mean when sigma is unknown, when the population standard deviation is not known and all you have is the sample standard deviation S, which is most of the time. Third bullet, determine the minimum sample size for a particular confidence level and margin of error. And finally, given a confidence interval, compute the margin of error. First of all, why do we want to compute a confidence interval? First of all, recall that if the sample size is reasonably large, if n is greater than 30, the central limit theorem ensures that x bar, the sample mean, has an approximately normal distribution with mean mu, the population mean, and standard deviation sigma over square root of n. Sigma, again, being the population standard deviation, n being your sample size. So we have this sampling distribution of x bar, which is bell-shaped, centered around mu, the population mean. So our sample means, our x bars, are normally distributed around mu. So instead of having just a point estimate, x bar itself, with no information concerning its accuracy or how good it is, we can calculate an interval estimate, x bar minus a margin of error E and x bar plus a margin of error E that has an associated probability or level of confidence based on this normal distribution. So first of all, constructing a confidence interval for a population mean when sigma is known. Step one, we find the z-score, z alpha over 2, where alpha is the complement of the confidence level, c. So alpha is 1 minus c. This is the critical value that cuts off a certain number of standard deviations on the normal distribution based on this confidence level. Then we calculate the margin of error, E, by taking that z-score times the number of standard deviations for this distribution, which is sigma over the square root of n. And finally, we add and subtract the margin of error to and from the sample mean to get the endpoints of the interval. For example, constructing a confidence interval when sigma is known using the normal distribution. Example 1. A random sample of 100 car engines has a mean weight of 425 pounds. Construct a 95% confidence interval for the population mean if the standard deviation of the population is 900. So we first note that sigma is given, it's 900, and we have C, the confidence level that we want, 0.95, the 95%. So alpha is the complement of that. 1 minus 0.95 is 0.05, or 5%. And then half of that, alpha over 2, is 0.025. So then from either a table of z-scores or the TI-83 or 84 calculator, we can find the z-score that corresponds to that, the critical value, by taking the absolute value of inverse norm of 0.025. And that's z sub 0.025, which comes out to 1.96. So that says that basically we want to go 1.96 standard deviations, almost 2 standard deviations to the right and left of the mean to capture this interval. So then we note that n, the sample size, is 100 car engines, and x bar, the sample mean, is 425 pounds. And again, sigma, the population standard deviation, is given to be 900. So the margin of error using the formula is E equals 1.96 times 900 divided by the square root of 100, which is 176.4. So the endpoints of the confidence interval then are found by taking 425 minus 176.4, which is 248.6, and 425 plus 176.4, which is 601.4. So the 95% confidence interval for mu is the interval from 248.6 to 601.4, which we give here in interval notation with parentheses around the numbers and a comma between them. We could also find this interval using the z-interval function on the TI-8384 calculator under stat and then tests, and use the stats option. Constructing a confidence interval for a population when sigma is unknown is a situation that we're usually in, because if we don't know the population mean, we most often don't know the population standard deviation either. So most of the time we have the sample mean and sample standard deviation. So in this case, since we don't know sigma, we have to use the student's t-distribution instead of the normal distribution. So the critical value is denoted by t sub alpha over 2 n minus 1, where again alpha is the complement of the confidence level, so alpha is 1 minus c, and n is the sample size. For the student t-distribution, we talk about a number of degrees of freedom, which is n minus 1. Then we calculate the margin of error by taking this t-score times the sample standard deviation s divided by the square root of n. And finally, add and subtract the margin of error to and from the sample mean as before to get the endpoints of the interval. Example 2. Constructing a confidence interval when sigma is unknown, we use the t-distribution. For example, a random sample of hours worked per week by student interns is drawn from a normal population with unknown mean and variance. The 7 data values sampled are as follows. We have a small sample, but it's okay because we have a normally distributed population. Construct a 95% confidence interval from U. So first note that sigma is not given. We have a confidence level again of 95% or 0.95. So alpha again is 1 minus that, which is 0.05, and alpha over 2 is 0.025. Here we have n equals 7. So n minus 1, the degrees of freedom, is 6. From the table then, table of t-scores, or from the TI-84 calculator, we can use the inverse t function, take the absolute value of inverse t of 0.025 comma 6, and get this t-score, t sub 0.025 comma 6, which comes to 2.447. Then you have to calculate the sample mean and sample standard deviation from the data. Since it wasn't given, we were just given the data, we have to calculate x bar and s. You can use your calculator, put the data into list 1, and do one variable stats to get this, or use technology of your choice, or use formulas. X bar comes out to 29.86, and s is 7.08. So the margin of error is calculated as the t-score, 2.447, times the standard deviation, 7.08, divided by the square root of the sample size, 7, which equals 6.55. So the endpoints of the confidence interval are 29.86 minus 6.55, which is 23.31, and 29.86 plus 6.55, which is 36.41. So the 95% confidence interval from U in this case is the interval from 23.31 to 36.41. Again, given in interval notation is most common. This can also be found with the TI-83 or 84 calculator using the t-interval function, which is under stat tests. And then you can use the data option where you just have the data in list 1. Next objective is determining the sample size necessary when you want to have a certain margin of error and you want to have a desired confidence level. So what should n be in order to have a desired confidence level and margin of error? So basically we take the margin of error formula and solve it for n algebraically, and you get that n is equal to z alpha over 2, the critical value, times sigma, divided by the margin of error e, the whole thing squared, raised to the second power. If sigma is unknown in this case, we can use S as an estimate. So if we don't know the population standard deviation, we can use the sample standard deviation. And then we always round this up to the next whole number, because this is actually a minimum sample size required, and sample size is always a whole number. So we want to go just above any approximation with a decimal. For computing the margin of error from the confidence interval, if the confidence interval is 2.44 to 9.12, you just take half the difference. The margin of error is going to be 9.12 minus 2.44, the whole thing divided by 2, or 3.34. And this is basically because the confidence interval is obtained by adding and subtracting the margin of error to and from the sample mean, so the interval always ends up being twice the width of the margin of error. So to get the margin of error back, you just take the width and divide it by 2. Computing the margin of error from the point estimate x bar in the confidence interval is even easier. And here what you just have to realize is that the point estimate, the sample mean, is at the center of the interval. Again, because the interval is obtained by adding and subtracting the margin of error to and from that sample mean, the margin of error is the difference from the sample mean to either endpoint. So if the confidence interval is 2.44 to 9.12 and x bar is 5.78, then the margin of error is either 9.12 minus 5.78 or 5.78 minus 2.44, both of which come out to 3.34. Thanks so much for watching this video on finding a confidence interval for a population mean. I hope you found it helpful.